Hi, and welcome to the Area of Interest Lab video. In this video, I'll be covering what material or what expectations are for labs, usually covering 5 and above. So first I'm going to talk about is the document for the Lab 5 Plus Area of Interest. And this briefly kind of tells you what the criteria is and expectations for these labs. So these are very open-ended labs where you get to determine what you want to do. And a lot of times these can go towards the final project that you're working on. So there's a very vast area of things we can do with microcontrollers or with interfacing with different devices. So with this, we're kind of allowing you to kind of find it with some help, little additional guidance if you need so. So the expectation of how complex the lab needs to be is the bare minimum to get data, right? Or get information or to test something. It's like a proof of concept. So it's not expectation that you have to have a fully vetted, fully working um, project or idea. It's really a hey, we want to get started, and what do I need to kind of just prove the concept, or I can prove I can get something valuable and make this work, right? So a good example I think explained in this is if we're looking for like a water moisture sensor, or should be sorry, soil moisture sensor. You're really kind of trying to grab that data. If it's a temperature, you just want to grab Fahrenheit or Celsius and just display it through UART or some other means to make it work. Um, so when so in some cases you might need additional hardware, but in some cases you won't need any additional hardware. So just keep that in mind as we're going through it. Um, Now, for lab reports, the expectation is that you will write them in like how-to format. So you're really going to just go through the steps you've done, what steps you followed. Now, I understand many people you're going to find tutorials online, you're going to reuse those. That's perfectly fine, but my expectation is to cite those sources. Make sure you reference to where you followed and what steps. I understand you're not inventing the wheel from scratch, and that's perfectly okay. But just please make sure you cite those sources properly. And all you're going to do is really go step by step on what procedure you follow to get to where you've completed. So next is just a list of topics. So again, I talked about there's a variety of different topics that we can discuss, right? That we haven't touched on yet. A couple of them being like UART, which is a type of communication protocol between two devices, Bluetooth. There's something called SPI, I2C, CAN. We have UDP, different TCP networking. These would really be handled by your Raspberry Pi. Now, I did list what my opinion for where you guys are at would be difficult. So CAN, I2C, and SPI can be fairly difficult if you're not as experienced with them. Now, they might not be too bad, but I recommend that if you do pick up some of these protocols like SPI, I2C, and CAN, where you have to build things on breadboards, that you do have some type of analyzer to look at them. So the Analog Discovery 2, it can look at or help you solve problems that you encounter. There's analog devices, there's some other devices. If you have type of digital or logic analyzer, those can help a lot. If you don't, if you encounter problems, it could be very difficult trying to solve. So I just want to point that out that it may not be the best approach with the current equipment that you have. Bluetooth can be fairly easy if you purchase these external monitors. So there's our external devices or dongles. It does cost a little bit of money. So if you choose not to, don't worry about it. You don't have to. UART doesn't require any additional hardware than you probably have done in your previous labs, and it's fairly easy. I even have a lab write up, and I'll show you where that's at on where you can do that. Displays, LCD, LED, OLED. So any of these can be used, but again, you would have to purchase different additional parts. Sensors, and some of these sensors actually might already be in some of the kits you have, so feel free to kind of research and look a little bit about it. But temperature sensors, humidity, IR, all of these you can get and use for your project. So there's also biomedical sensors if you choose to do in more of those realm towards your projects, as well as different, I label as control, but really are kind of electromagnetic devices like DC motors, stepper motors, servos, um, you know, how to use H bridges, motor encoders, relays, solenoids, all of that. And then we get into some digital signal processing concepts. Um, these don't require usually any additional hardware. You really just need a way to generate a signal, and that might be simple enough with what you already have on hand. If you have an analog discovery 2, it's great because you can generate a multitude of signals and then work on writing some different things. So we can touch on some low pass filters, high pass, band pass, peak detection, LMS, or adaptive type filters. You also, things we can touch on some power related things is measuring output from power, from different devices, trying to leverage some of the utilization of power registers. This might be a little bit trickier, but it is an option if you choose to spend some time on it. There's also different sensors you can look at purchasing that measure current, and stuff like that, which might be really useful for what you guys are looking at. And then there's some data are called Internet of Things, and this is things of how we look at things reaching out to the internet that can be controlled externally. And this is very base level. Data logging kind of falls under that a little bit in a very low level, but you have different types of things like web servers. You have static and dynamic, where you can take user input, syncing devices to other computers, sending emails, or sending text messages, or a couple of different things. So again, labs, 5 or 6, 7, 8, whatever, whatever's beyond that lab 5 description are supposed to be very simple labs, not to be complex, just to prove a concept. And the purpose isn't to look at it as very focused in your project. And I say that as, I'll take the example of a temperature sensor. A temperature sensor can be used for, a smart garden, or it can be used for a remote weather station. But I want to just go as far for my lab 5, if that's my temperature sensors on my project for lab 5, as far as I need to, that I can take that concept from the temperature sensor and apply it to either one of those projects. So don't focus on the project itself. Think as this is the first baby steps towards your project. So I hope this helps. If you have any questions, feel free to talk to your lab instructor and look for more videos.